So today is the last day that we're covering new stuff. And then we've got the review day next day where we'll go through practice test 3, and then we'll have test 3 on Monday, no class on Wednesday, remember? And then 2 review days the following week. So today, oh, here, hang on. 1, 2. Did you get a practice test?
Oh, no, yeah.
There you go. No worries. Today, we will finish all material. Whee! What's nice about chapter 8 is it's only one little section, and it's on mortgages, which is the same of what we have been doing. So that's why we're gonna just zip through it like it's no big thing. So here, what did we say? So today we're gonna finish all the material. On Wednesday, we're doing test number 3 review. So same thing as last time, you're gonna upload your practice test on Moodle before the class, and then we'll go through it together and you'll get 1 completion mark. On Monday, April 1st, not a joke, you've got test number 3. And then, oh, not Monday. On Wednesday, April 3rd, no class. Right, we talked about that last day, and I've decided it's a good plan. We'll just have no class because I won't have, it's a busy week, so I most likely won't have test 3 marked, so we can't go through that. Otherwise, that's something we could do. I only have 2 days of final exam review, so it would just be an empty space day anyways. So we're gonna do no class on Wednesday, and then Monday and Wednesday we'll do final exam review. So let's do a little bit of review because it was a while ago. What did we do? So last day we talked about chapter 7, which was on annuities due, right? So we talked about annuities due, which is when payments are made at the beginning of the payment period, right? That's the only difference. Are made at the beginning of the payment period. We talked about how it changes. So it changes the timeline, right? It moves all your payments to start today, and then it ends the payment period before the last one, right? So it just shifts all the payments over in your timeline. It changes the formulas a little bit, but not that much, right? We've just got the times 1 plus I typically somewhere in there. And yeah, besides that. Oh, and the BGN setting on your calculator. All right, so we talked about those. How do we change from beginning to end on our calculator? And we talked about deferred annuities. Let me see if I can. Oh yeah, and we did a doozy of an example, but we talked about deferred annuities. when there's some deposit and then it sits there for some amount of time, and then we get our payments. So we've got some initial deposit grows for some amount of time, then payments start. Right. Or the other way around, you buy something, don't make any payments for the first year, then you're deferring your annuities, right? And so you still have to pay that, even if it doesn't seem like it, right? Then you're saying, okay, I'm going to put off these payments for a year, and then I'm going to start making payments, right? So that would be a deferred annuity. And then we talked about perpetuities. We didn't have a chance to do an example, but we will right now. And it's going to be similar to practice test question 4. Yeah, practice test question 4 is going to be like the example that we're about to do. So perpetuities are just when we, from some initial, so from some present value, we will get payments. We will get PMT amount, I'll just say PMT payments forever. And we said that the present value of a perpetuity is the payment amount over I. Where's all my stuffs here? Yeah. Where I, right, sometimes has to be I2 to match the payment frequency, right? So we often need to use I equal to I2 to match the payment frequency, or to match the desired payment frequency. And if we want these payments, right, going on forever but starting immediately, right, then we have a perpetuity due. Right? And so then we could do a present value of a perpetuity. That's just how much do I need to deposit to sustain payments at an interest rate of I. So a present value of a perpetuity due is the same formula, the payment amount that I want over I, and the only difference is that if I want to start right away, then I have to have that initial amount ready to go, right, plus PMT. But that's the only difference.
What would ever discontinue payments?
I guess technically, someone told me last term that technically you can't have a perpetuity forever. They cap it at 72 years or something weird like that. But yeah, what would happen? I guess they would have to pay you out, because you would still have that initial amount, but could not end well. But yeah. So, and then we didn't get a chance to do an example, so let's do the example now. So kind of new stuff. But yeah, any other questions about that? Oh. All right. Example 232. donation of $350,000 is made to support youth sports in Kelowna. In order to hire a part-time administrator, the organization requires $25,000 annually at the beginning of the year in perpetuity, so forever. How long should the organization invest the $350,000 for at a rate of 5.5% interest compounded semi-annually so that they can hire the administrator? So now we've got not a lot, but a few things to keep track of, right? First thing is, okay, we need to make our payments at the beginning of the year, right? So we're at the beginning, which means we have a perpetuity due. We need payments annually. So the payments per year is 1. And our compoundings per year is semi-annually, so 2. Which means we have to find I2 before we can do any calculations. Our compoundings per year is always our F1, and our payments per year are always our F2. I1 is R over F, and R1 over F1, doesn't matter. 0.055 over 2. 0.0275. Best just leave it to the calculator. 0.055 divided by 2. Hey, not bad. 0.0275. So first thing I'm going to do, because my payments per year and my compoundings per year are not the same, I'm going to find I2 because that's the one that I'm going to use in my calculations. And then I'll kind of have a look and see what's going on here. So I2 is 1 plus I1 to the power of F1 over F2 minus 1. Right. Yeah. So we've got 1 plus 0.0275. So loud today. Over 2 over 1, or to the power 2 over 1 minus 1. So plus 1 to the power of 2 minus 1. I get 0.055756625. I'm going to store that in 1. Okay. So now let's kind of get down to what's going on here. So there's $350,000 that's being donated, and then it's going to sit there for some amount of time until it can handle payments of $25,000 starting today every year forever. Okay. So what we have to do is we have to figure out, okay, well, what do we need in order to sustain these payments of $25,000 every year? And then how long is it going to take $350,000 to grow to that amount? And then how long should the organization invest the $350,000 for so that they can hire the administrator? So in terms of a timeline, we've got today, they're going to invest $350,000, and then at some unknown time point, this is going to have grown to some future value where it can sustain payments 1 year, 2 years, 3 years, and then because it goes on forever, I'm just going to do an arrow and then ... and just show that it keeps going on forever. I'm actually going to change this a little bit here, only because we need the payments to start at the first time point here at the question mark, right? Because we want the payments at the beginning of each year. And so we need a payment here, a payment at 1 year, a payment at 2 year, and a payment at 3 years. So for perpetuities, as long as you show the first, I don't know, 3 ticks, I went to 4, but as long as you show 3 or 4, that's good enough. So then these payments, we can figure out what present value we need to sustain these payments forever by pulling them back to some present value of a perpetuity due, just because they have to start on the same day. And that has to be equal to that future value. So we're trying to figure out how long this arrow is from today to the question mark. And we'll do that by saying, okay, well, we need a payment at the beginning of each year forever. What do we need to sustain that? I guess instead of PMT, I should have put 25,000. Okay. Easy for me to do. Kind of screwed it up for you guys, didn't I? 25,000, 25,000. You could just make a side note saying where PMT equals 25,000. So the first thing that we're going to do is we're going to find the perpetuity due, the present value of the perpetuity due that we need. Okay, and so the present value of a perpetuity due is the payment amount over I plus that initial payment amount that you're going to have ready to go. And so our payment amount was 25,000 over I, which is going to be our I2, right? Because we had to adjust so that our compounding frequency is the same as our payment frequency. And so we have 0.05575625 plus the first 25,000. So we've got 25,000 divided by recall 1 plus another 25,000. I get 473,380.2264, which in terms of money, right, is 473,380.23. So 473,000 every year we'll be able to skim off the top 25,000, and it doesn't affect the principal amount that's being invested. That's kind of cool. So here we would need $473,380.23 in the bank to earn $25,000 in interest at the beginning of every year. Busy class today. In interest at the beginning of every year. The beginning of every year. Forever. That says forever. So that's all fine. So now the next question is, well, how long is it going to take for 350,000 to grow to 473,000? So how long will it take 350,000 to grow to 473,380.23? You can do this on your calculator, or I'll just do it by hand just for some more practice, right? But you definitely could do it on your calculator, just finding n. And what I'm going to do is I'm going to just keep I2 as my periodic interest rate. So I will use I2 as my periodic interest rate. Keeping in mind, right, that that's being compounded annually, right? So F is now 1. Keeping in mind, F is now annually. I'm picking that one because we're going to have to convert it to years anyways. So if it's already annually, then it saves a little bit of work. Right? So this is just one of those regular compound interest problems, right? We've got some present value has to grow to some future value. How long is it going to take, right? And so you know from your formula sheet, the first page, you've got the formula for n. N is the log of the future value over the present value over the log of 1 plus I. Remember, n is now the number of compoundings. Right. Whenever we're back to just compound interest, right? Some amount grows to some amount, there's no payments involved, or no regular payments, I should say, then n is just the number of compoundings. So we've got the log of 438,380.23 divided by 350,000 over the log of 1 plus point, and I'll just steal it from here, 0.05575625. 473,380.23 divided by 350,000. And then the log of that is 0.30196578. And then 1 plus recall 1. And then the log of that is 0.054257,335. Yeah. Uh-oh. 73. I know, but it's I was wrong. Should be 473. You're right. Is that what you're commenting on? This number is wrong. Uh-oh. Okay, here we go. Thank you for catching that. $473, right? changes this. I'm going to store this, I don't know, in 5 or something. And okay, 473, 380.23 divided by 350,000. And then the log of that is, I get 0.30196578. Is that what you guys are getting? Yeah. Cool. And then divided by, recall, 5. Oh, I can check it. Yeah, okay. I'm on the right track now. I get 5.56543728. For n is the number of compoundings, right? We can't do a partial compounding, and so we're going to have to do a full 6 compoundings. Right? So we would need n equal to 6. So now, as long as we remember that n is time times the frequency, and we remember that f is now 1, right? We've got 6 is time times 1. So time is just, it would take 6 years. If you have a read through question 4 in the long answers on your practice test, and if you don't have a copy of the practice test, you can grab one after. Very similar to that one that we just did. So, any questions about that one? All right. Well, let's get into chapter 8, shall we? All right. So chapter 8 is, if you didn't get a handout, or actually there was 2 handouts. And like I said, if you weren't here last day and you didn't get a copy of the practice test, then just come grab one after class because I have lots. All right. So chapter 8 is kind of like this special case of mortgages. Well, I posted it on Moodle if you want. Yeah. I know. It works. So call me crazy, but it works. And so what we're going to do in this section is we're going to write out amortization schedules. Of course, you would use something like Excel to do this, but we're just going to do partial amortization schedules. So what do your first couple of payments look like? And we're going to talk specifically in terms of mortgages. Of course, it goes for any sort of loan that you're paying back, right? And so how loans work is in the beginning, you're going to be paying a lot towards the interest, right? So we're making the same payment, right? To us on our end, it always is the same payment, but in the beginning, a lot of that payment is going to be paying off interest, and some of it is going to be paying off the principal, right? And then as we make more and more payments and we pay off more and more of the principal, then there's kind of a shift, and then we start paying off less interest because there's less owing, and then the amount going towards the principal is higher, until eventually everything's all paid off, and then you're free, right? And so that's what we're going to do today, is just look at, okay, how do we fill in these amortization schedules? And probably if you looked at the practice test, you saw the last question was just a mortgage question, fill in this table, and yeah, calculate your payment amount, fill in some payments, and then what was the total amount of interest that you paid. And if you have a read through all these practice questions that I've given you, they're all about the same, right? Find your payments. How much are the payments? The 112th payment, the 200th payments, right? And then how much in interest did you pay? Yeah. So we're going to go through one together, because that's going to be enough, I think. But then I'll post the solutions to all three of these ones that I gave you, and also this written assignment that is definitely just for practice, so you don't have to hand it in. I'll post the solutions to that one as well, and then we'll do the practice test next day. So you'll have seen lots of them. Okay. So, but first, let's talk about just basically what each of these categories are and how they behave. So we'll talk and develop some terminology to start. So chapter 8, mortgages. It's probably my favorite chapter. Is it because it's the last chapter? Maybe. I don't know. I always think it's really fun to have seen all the material in a course, right? Because then it's like you've seen it all, and then we can just go back over it and review it and that kind of stuff. So first, we're going to define an amortization schedule. It's a schedule of payments with a breakdown of the principal amount, which is how much you're paying off the amount that you borrowed, or also could be the balance, but usually it's the amount that you're paying it off by. The interest amount and the remaining balance. To make these and to fill in these tables, there's just a list of facts that we're going to go through. Okay. So here, facts. Fact number 1, the first payment number will always be 0. The first payment number will always be 0. With blanks across the first row, except the balance will be the face value of the loan. So with the blanks, with blanks across the first row, except the balance, will be the face value of the loan, right? How much did you initially borrow and that you have to pay off? The face value of the loan. So you can always start with that, right? Your first payment number will always be 0, and then blank, blank, blank until the balance, which is going to be your first payment, or sorry, the total amount that you've borrowed, that you're paying off, your balance. 2, so your second fact is that the payment amount, right, if we're thinking about car payments, mortgage payments, right, they're not changing, they're the same every month, right? And so your payment amount is going to be the same for all of these except for the very last payment. The very last payment is you have to usually pay a little bit more, or just do like a little square up payment just to make sure that everything is paid off. And so the second fact is that the payment amount will be the same for every payment except the very last payment, where everything must be paid off it could be a partial payment. Moving across, we're going to be calculating the amount of interest that we're paying, right? So we've got our payment amount and then the amount of interest that we're paying. And how we're going to calculate the amount of interest that we have to pay for each payment is we take the previous balance times the periodic interest rate. Usually we're going to have to find I2, right? Because we've got some compounding frequency and some payment frequency. And if they're not the same, we're going to have to find I2 and use I2. So fact number 3. The interest amount will be the previous balance times the periodic interest rate. Often we will need to use I2 if the payments per year is not the same as the compoundings per year. Right? But we find I2 the exact same way, so nothing's really changing. And then we just use I2 in our calculations. We keep going, right? So that's your interest column. And so each of those interest values is going to be the previous balance times I2. For the principal amount, that's going to be your payment minus the amount of the interest. So whatever's left over from your payment, once you've paid off the interest, that amount is paying off the balance, and that's your principal. And so fact number 4 is the principal amount will be the previous balance oh, sorry, I skipped one. The principal amount will be the payment amount. The payment amount minus the interest amount. Minus the interest amount. So you can see once you've filled in a few of these tables, I don't know, they're pretty fun. Okay. Finally, we're in the balance column, right? The balance is just the previous balance minus the principal of that line. Okay. And so the balance will be the previous balance minus the principal amount. The last row, so that's how all the rows behave, except for the last row. The last row is kind of different because now we need the balance to be 0. So, but we also have to pay off the interest from the previous balance. And so that's going to dictate what our principal amount is, what our interest is. And then we add those up to find what our last payment amount is going to be. So fact number 6, to calculate the last row, first step is set the balance to $0. The previous balance has to be the amount of the principal. So set the principal to the previous balance. I'll say to equal the previous balance. Third, calculate the interest amount. Calculate the amount of interest. And that's going to be the same as you have been doing, right? Just taking the previous balance times I2. That's how much you have to pay in interest. And then the final payment. Final payment is the sum of the interest and the principal. That way you're all paid up. You've paid off your balance as well as any interest that you've accumulated. Okay. Any questions before we do this example? So I've just stolen these examples out of the textbook, of course, but it's good to get some practice. So we're just going to do example 236 together, and then you'll be able, I'll post the solutions to the rest of them, but you'll be able to do them on your own. Where did I I gotta pull them off Moodle. Oops. Eek. Should have done this beforehand. Sorry, guys. So it's called that Chapter 8 worksheet. The solutions are already up. Open in Notability. So I'll just steal this here. And then I'll steal that table a little bit later. So Norm wants to purchase a home in West Kelowna for $308,000. Don't we all? He intends to make a $100,000 down payment, with the remaining payments being made bi-weekly over a 25-year period at 4.7% compounded monthly. So just like before, right, we're just going to highlight, okay, so we're compounding monthly and we're making bi-weekly payments. So just to highlight here, our payments per year are bi-weekly, so 26, and our compoundings per year are monthly, so 12. So we know we have to find I2. Right. It doesn't specify if the payments are being made at the beginning or at the end, so the default is at the end, right? But we could just as well say he wants to make payments at the beginning of each bi-weekly period. Right. So we can say, and since it doesn't specify, we are going to use our calculator to do all of these calculations, right? So not to worry. Okay. So he wants to buy this home for $308,000, but he's also going to pay off $100,000 right away. So the loan amount is really only $208,000, right? Because 308 minus the 100,000 down payment. So what I'm going to say is the present value is 308,000 minus 100,000 . This is the face value of the loan. Let's just calculate I2 just so we have it, because we know we're going to have to use it to calculate the amount of interest every time. And so we've got I1 is R over F, which is 0.0475 compounded monthly. 0.0475 divided by 12 is 0.003958333. Better store that. I sorted in one. I2 is 1 plus I1 to the power of F1 over F2 minus 1. Compoundings per year is our F1 and payments per year is our F2. And so we've got 1 plus 0.003958333 to the power of 12 divided by 26 minus 1. Okay, I get 0.00182498. I am going to store this in 1. It's going to be important. So we know how much the loan is for. We know the periodic interest rate. So that's all good. And we're going to construct a partial amortization schedule showing details of the first 2 payments, payments 324 and 325, and then the final 2 payments. And then what are the net interest charges? And so the total number of payments is what? Is T times F, where F is the number of payments or the frequency of the payments, 25 years, I think, right? Over a 25-year period, so 25 times 26. He's making 650 payments. So what we can do is I'm going to steal this, and I'll just make copies as we go, but you just need 1, right, to fill in. So now we know, okay, the first payment number, just from that first fact, the first payment number is 0. But now we also know that the last payment number, if there's 650 payments, the last payment number is 650, right? Then we're done. So what we can do is we can fill in here 650. And we wanted to see in the question, where do I have it here? I want to see the first 2 payments, so 1 and 2, and then I want to see payments 324 and 325. So I want to see payment number 1 and 2, ... Just as a spoiler alert, just so you're aware, in order to calculate payment number 324, we actually need the information from 323. And so I'm going to put 323 on here, and then 324, and then 325. And I want the final 2 payments, well, that's 650 and 649. But again, in order to be able to do all of 649, I also need the 648th payment, or the balance at least. Okay. So far, we know how many payments we have, and we've just filled them in, and we know which ones we have to fill in from the question. We also know by our facts, right, that the first row is just blank, blank, blank until the balance, which is the 208,000 that we're trying to pay back. Next thing we have to do is we have to calculate the payment amounts, right? And if this was just a standalone question, you could do it quite easily, right? If it's compounding this and you want to make payments bi-weekly at the end of each bi-weekly period for 25 years, what's your payment amount, right? So we need to calculate the payment amount. For me, I'm just always going to do this on my calculator just to be safe. And so N interest per year, present value, PMT, future value, payments per year, compoundings per year, and beginning or end. So my N is 650. The interest per year is 4.75. The present value is going to be the amount that I'm trying to pay off, right? The 208,000. So 208,000, and I borrowed it, right? I got it, and then I chose to buy a house with it. But that's why it's going to be positive. The payment is what I'm trying to find, so I'll put a star by it. The future value when I'm done paying will be 0. My payments per year were 26. And the compoundings per year were 12, and we're at the end because it wasn't clear that it should be at the beginning. Right? If it's at the beginning, it'll have to say payments were made at the beginning, whatever. So using our calculator, we just plug these in. 650 and 4.75 interest per year, 208,000 present value, 0 future value, payments per year is 26, enter. Compoundings per year is 12, enter. I'm at the end, compute my payment, and I get negative 546.730574. That just means I have to make these payments, right? That's why it's negative, right? So it's not a negative amount, it's just I have to make these payments. And so my payment will be $546.73. And I'll put in brackets for all payments except the last. So now I can fill that in. And like I said, I'm just going to keep copying this table as I fill it in. Oh. Yeah. So now each payment is $546.73. 546.73 ... 546.73. 546.73. ... until the very last one. This one is going to be different. We don't know what that one is quite yet. But all other payments are all the same. So you know what that value is. So we know I2, right? We've got it stored in 1. And so to calculate the amount of interest that we have to pay, right, we're going to take the 208,000 times I2 to find the first amount of interest that we have to pay. And so what I'm going to do here is I'm just going to say, okay, well, here I've got this green box is going to be 208,000 times I2, which is 208,000 times recall 1. 379.5958521. But because this is money, we always have to round to just 2 decimal places. So 379.60. So now we know that we have to pay $379.60 in interest on that first payment. The principal, right, is just going to be, okay, well, how much is going to actually pay off this loan, right? You've got your payment amount, that's all you have to play with, minus the amount of interest, right? Once the bank has taken their interest, then the remainder is just going to go to pay off the balance. So this is going to be 546.73. Or actually, I'll do it in general first. It's going to be the payment minus the interest, which is 546.73 minus, what was it, 379.60. 546.73 minus 379.60. It's $167.13. That's a lot to interest and not that much to pay off your loan, but it's okay. So here we've got 167.13. So now the balance here, let's see here. Sure. See the difference in the colors? Not really. See if I can find a better color. It's hard on this screen though. They all kind of look the same. How about that blue one? A little bit better. So the blue one, that's going to be your previous balance minus the principal. So that's your previous balance minus the principal, which is your 208,000 minus 167.13. Now you owe $207,832.87. So we can fill that in. 207,832.87. Now I'm not going to show the work, but we'll just fill in the table for the next line, right? Because now that you've got the previous balance, you can just multiply it by I2, which I've got saved in recall 1. And then you'll be able to just fill in the amount of interest. So I get 379.29, a little bit less. Not much, but a little bit less that I have to pay in interest. And so now 546.73 minus 379.29 The amount going towards the principal now is 167.44. And so take that off the 207,832.87 minus 167.44. Now I owe 207,665.43. Check that I did that. Yeah. First couple of rows are fine, right? Because we know the principal value, the face value of the loan. To fill in lines 324 and 325, right? All we need is the balance at 323. What you're going to do is you're going to use your calculator to calculate the future value, right? After payments of 546.73, right? Now you know your payment amounts, and the payment number 323, that's where you're going to find your future value. So I feel like I should start fresh so I'm not scrolling up and down a bunch. Copy, paste image. That's what I want to do. Okay. Actually, move this down a bit to make a note. Doesn't really affect you guys because it's all on one sheet, but to calculate rows 324 and 325, we need to know the balance at row 323. So to calculate rows 324 and 325, we need to know the balance at 323. So now we've got N interest per year. I'll make a little bit of room here. All right, because we're just going to use our calculator again to find the future value at N equal to 323. So we've got N interest per year, present value, payment amount, future value, payments per year, compoundings per year, and beginning or end. Notice what's nice is a lot of these are going to stay the same from the one where we calculated the payment amounts, right? So N is now going to be 323, and the interest per year stays the same at 4.75. The present value is still 208,000. But now we've got these payments, and just remember to make them negative, because if both the present value and the payments are negative, that's like borrowing 208,000 and then every biweekly period borrowing another $546, right? So you want to have that negative so it's actually paying it off. So negative 546.73. Future value is the one I want to find. The payments per year were 26 and compoundings monthly, so 12, and we're at the end. But remember what's nice about the calculator is you only have to enter new stuff. It'll remember the previous stuff. So I do have to change my N to 323. My interest per year is the same. My present value is the same. I have to enter my 546.73 negative as my payment amount. And then I can just compute my future value. So at payment 323, the balance is negative 134,546.1137. So the balance at payment number 323 is 134,546.11. I'll use this dark green one to say that, hey, this is the one that's going here. So we've got 134,546. Oops. 0.11. The rest of it at that line we don't know, but that's okay because all I'm asking for is 324 and 325. So you always have to go to the one previous, find the future value there, and then calculate it. But now that we have the balance from the previous one, this is essentially the same setup as we had for the first two, right? As long as you know the balance of the previous one, you can find the whole row. So now we've got 134,546.11 times recall 1. Now the amount I'm paying in interest, let me just double check that I did it right, yeah, is 245.54, rounding to 2 decimal places. And once I've paid that off out of my 546.73 minus the interest that I'm paying, 245.54, the amount that I'm now paying towards my principal is 309.19. Right? So at some point there was a shift where, okay, now I'm actually paying less in interest than I am in principal, and I'm going to be able to pay this off a lot faster. So 134,546.11 minus 301.19 is 134,244.92. Times that by I2, you'll have the interest for the next line. So times I2, 244.99, rounding to 2 decimal places. 546.73 minus 244.99, 301.74. Take that off the previous balance, 134,244.92 minus 301.74. Now we owe 133,943.18. And there's little dots in here, but you don't, it's just for fun. Okay, same idea, right? But now we have to find, okay, so we want the last 2 payments, which means I need 649 and 650. But to get 649, I need to know the future value at 648. But what's nice is everything in this calculation stays the same except for your n, right? And so now you just change your n. And so now find the future value at payment number 648 to fill in the last two rows. And interest per year, present value, the payment amount, the future value, the payments per year, the compoundings per year, beginning or end. Now we need it at n equal to 648. Interest per year is still 475. The present value is still 208,000 positive. The payment is still negative 546.73. Future value is the one we want to find. The payments per year is still 26. Compoundings per year is still 12. And we're still at the end. Just to highlight, this n is the only new thing, right? So that's the only thing you have to update. Same as before here, the only thing you had to really update was those two, n and the payment amount. So changing 648 into n, and then I can compute my future value. I get a future value equal to negative 1,091.18574.9. So the balance at payment number 648 is, in terms of money, 1,091.19. I'll clean that up a bit. And I'll just draw a little arrow. I'll copy this actually. Copy. So then this 1,091 is the value that goes in there. Right, behaves the same way. I wonder if I can erase this little guy. Can't. He's stuck. It's okay. I guess I could use a white pen, but anyways. Feels like something I'm gonna do. There. So now we know the balance at the 648th payment is 1,091.19. At that point, I'd be too excited and I would probably just want to pay it off. Screw the last two payments. Here you go. Bank doesn't like that very much though. We don't know anything about the interest or the principal, but that's okay, right? We only needed this line for the balance there. Okay. Home stretch here, guys. We still have to find the interest that we're owing. So 1,091.19. It's important when you're dealing with money, right? So at each point that you found the dollar amount, now you're going to round to 2 decimal places and use those values. Right? So 1,091.19 times I2. Now I have to pay $1.99 in interest. That's pretty good. And 546.73 minus $1.99. So now $544.74 is paying off my balance. That's really good. 1,091.19 minus 544.74. The last amount that I'm owing is 546 45. Okay. Remember that things change for the last payment, right? The last payment, we have to, okay, so we have to have a balance of 0 here. Otherwise, we're not done, right? And we also have this much left owing. And so this amount has to be here, right? Because that's what we have to pay off to make this 0. And then we also have to pay interest on this amount the same way that we've been paying interest before. So we're going to find an interest amount and we're going to use this previous balance as our principal amount. And that's how we're going to find the last payment amount is going to be this plus this, the principal plus the interest amount. Okay. So I'm going to force this to be 0. And then this here, that pink box, must be 546.45, right? The previous balance. So here we've got 546.45. We still have to pay interest, so times I2. 0.9972, so rounding properly, we get an even dollar in interest. And now, to get this orange box that we've had kind of lingering for a while now, that's going to be the interest plus the principal, which is $1 plus 546.45. So the last payment is 547.45. I'll just put in brackets here that this is the final payment. Okay. That's usually a pretty good check if I'm marking, and this is the last test, or it's the last question on test 3, but it's also the last question on the final exam. So at that point, I don't know, I'm just pretty keen to get it all over with and marked. My first check is going to be, did you get the right final payment amount, right? Because if you got the right final payment amount, odds are you did the rest right. Because then I can just look, okay, if that's right, I'll just kind of skim through here. Okay, everything looks good. Great work, right? So you want to make sure that you get that last payment amount right. Otherwise, I'll have to dig deep and see what happened in there. Right? But if it's right, then moving on. Any questions about that one? Yeah. It's just going to be the same thing as before, but it's the 546.45 times I2. But you have to round to just 2 decimal places because I get 0.997. So as money, it's just 1. So then the last part of the question is, what are the net interest charges? So what are the net interest charges? I think on this extra practice problem that I gave you just for fun, I asked what was the total amount of interest paid on the mortgage? Same idea, right? You'll have something similar on the practice test and on the test. But how do we figure that out? Well, we borrowed 208,000. Right? We also know that we made 649 payments of 546.73 plus the last payment of 547.45. Right? And so that's how much we paid minus how much we borrowed. Everything else is interest. Right? Because technically what you would have to do, you would have to add up this whole column, but because it's constantly changing, that's really kind of tricky to do / impossible. So the net interest charges, we're going to find the total paid is 649 payments of $546.73 and one payment of $547.45, which is 649 times 546.73 plus 547.45. $649 times 546.73, $354,827.77 plus 547.45. So the total paid is $355,375.22. Total interest paid is the total paid minus the value of the loan. The total paid was $355,375.22 minus 208,000. So the total interest is $147,375.22. Yikes. Basically, it cost $147,000 to borrow $208,000. Oof. But definitely go through and work through these other ones, just filling in the table, right? Figuring out, okay, what's my payment? How much do I have to pay in interest? And then the solutions I've posted on Moodle already for these ones. And I will post the ones for the written assignment, which is not an assignment at all. It's just another practice problem that you can do. Right? So not do. Any questions? Are you guys excited that we've covered all the material already? Because I am. I'll see you guys for the review on Wednesday. Ooh.